Hello and welcome everybody. In this video we are going to discuss how to manipulate the data to generate our CSV files, and also we're going to do some fundamental statistical analysis on the data that we have. For that I have one single Excel file that has two worksheets. In the first worksheet we have one column of data, and in order to prepare this for doing the same problem in R, I am going to save both of these worksheets into CSV files, and that's how I'm going to start. So in order to do that, just go to File and then Save As, and then you select CSV and then you select the directory that you want to use. I'm going to just go ahead and do it in the downloads, which is my default for saving when I don't have a specific needs. And that saved just one worksheet. It's a flat file, meaning that there are no links, there are no formulas, it's just the data. If I go to worksheet number 2, I also have the data, but I have two columns, and I can do it again. And if I do save as, it's going to try to save the same file. So I need to be careful on my selection of what I want to do. If I do save, it's asking if I want to replace. So since I don't want to replace that, I'm just going to say, well, this is the second CSV file, so I add a number 2 at the end and I save it. And now those two files are not Excel files. This one is Excel file, and I need to save it if I want to keep save it as an Excel file if I want to keep the changes that I will do. So let's work on the first one. Here is of course the data, and if we are interested in computing the mean, the median, we can, there are basically two ways you can do that. One is use formulas, and the other is use the toolkit. Excel has built-in formulas for financial applications, summation, statistics, and other things. If you go to the top right corner of the menu at home, you will see that you have functions by different families: financial, date and time, math and trigonometry, statistical, and others. If we go to statistical, you see you have average, if, average ifs, and others that may be of interest. There are also distributions, theoretical distributions, like the binomial distribution, the chi-square distribution, the normal distribution, the exponential distribution. Also you have standard deviations, counting under conditions like an if, computing of variances, covariances, standard deviations, and tests like the feature test, and so on. So it's very complete, but you need to know how to manipulate the parameters in each one of these functions. We're going to see a few of them. In this case, if we wanted to start with computing maybe how many we have, we can just count, and that would give me the count 922. If we want to have the sum, that would add all of those data points, and that's a total. We can format so we can make it more attractive. Change the size here at the bottom right, and it's better for the video. and we can compute the median. The median is the point where 50% of the points are to the left or are less than, and 50% of the points are to the right. So compute the count. We have not computed the average. The average would be the total divided by the number of points, 999.74, but Excel can compute that for you as well. The way that I am navigating this, I'm going to explain. Let me do that again. I type in equals and then open and then type in the formula average and then open the parentheses, and it gives you the prompt. In order to do this as fast as possible, I navigate with the arrows on the keyboard, then I press Shift and down, and it will go as far as the data is continued. In this case, 922 rows. Then I just close the parentheses and hit enter, so I don't have to do the mouse and scroll down and select like this. It's too slow for me, so it is faster using the keyboard for the most part. Very good. What else we would like to do? We would like to maybe create a histogram, and in order to do the histogram, let's see what Excel has. Excel has recently upgraded a few things to make it more powerful, especially now that people are expecting to be able to exploit the data. But let's go with the basics. Let's see if we can insert a chart. Here you have a histogram, and yeah, it looks like we should be able to insert a histogram. So let's select the data again using the Shift and down to select histogram, and there you go. You have a histogram right there. I'm sure we should be able to have some parameters here, like some of the aesthetics, kind of nice. Let's see, with respect to the data, can we select? We didn't insert actually. I'll do it again. Insert the histogram. Okay. If I go in there, chart elements, I can have the titles in the axis, data labels, yes or no, legends. Let's see, what else can we do? We can change the style, but it's not readily letting me decide on the number of beans. But for purposes of getting at least a histogram, we have that. Also, I saw that if you selected that again, oh, here it is. Actually, we got it. This one ended up at the bottom. So let's move it up. Now for this one, maybe we don't press Ctrl X. Here, Ctrl V. There you go. That makes it faster. Ctrl X, Ctrl V. And I'm going to create now a Pareto chart. I select all that, insert Pareto chart. Now it's sorted by class. Of course, these classes are sorted by the frequency, but it's not easy to see which are the values because they get truncated, and maybe it's not as relevant to use a Pareto chart when you have on the x-axis just numbers. It'll work better when you have causes for failure or things of that nature. Alright, so that's our Pareto chart. We can create box plots in in Excel, and again I move this to the bottom because when I select that range, X Control V, erase that chart, Control X, apologize for all this mess, and Control V. Very good. Now what we're going to do is we're going to create another type of chart. In order to be able to see them better, you can select them all, and we're interested in a box and whisker plot. Take the data again from here where I wanted to have it, and that's it. That's what we have. What this means is that the average is very close to 1000. 25% of the of the samples are above this point, around 1057, and about 25% of the data is below 941.38. You can see these are long tails, and then you even have some points that are beyond the 3 sigma levels, be probably considered outliers. So this is your fundamentals for that analysis in Excel using the formulas and the tables. Now we can go ahead and use the toolkit. The toolkit is very powerful. We go to data. I already showed a video on how to install it, so I use data analysis, and I have a window that pops up, and I want to do descriptive statistics. I hit OK. The input range, I select the column, and the output range, I can go to a different worksheet, or in this case I'm just going to use this space to the right. Just let's see the summary of the statistics. And for those of you who are familiar with the test of hypotheses and so on, we have the confidence level at 95%. We can change that, and we say and it goes ahead and computes all this data for you very nicely with the same mean and the same median. The mode in this example, since it's continuous, it doesn't have a real. We have standard deviations, sample variance, the kurtosis and skewness. The kurtosis and skewness gives you a measure of how thick are the tails. If they are too thick, it means that there is too much variability compared to a normal distribution, and that may be a problem in terms of when we think about it. There is variability that may not be explainable by normal noise. There may be special causes when the thickness of the tails is too big. The skewness represents if the tail distribution is long tail in either direction, left and right. And then you have the range, the minimum, the maximum, the total, the count, and the confidence level. So this is the fundamentals of how to do this using the toolkit. If you run the toolkit for 2 columns now, we can do that, and we can request the data to be analyzed by column. So we have the input is going to be A and B this time, and the output we're going to place it closer. Alright, and the data is grouped by columns, and there are no labels on the first row. If we run it, and what we have is an analysis of each column separately, containing the same data that we had before. Very good. Now, using some of the formulas that Excel has, you can compute, say for instance, the binomial distribution. The binomial distribution has a parameter n for the number of attempts or trials, and then a number x for the number of successes, and then the probability of success at every attempt in each attempt, and then the binomial is trying several times the same experiment and see what's the probability of having exactly that. So in this case, let's work an example. Let's say the total trials is 10, and then x, we're going to leave it alone for a moment because what we want is to compute every single possible result. And let's say that the probability of having a success is 20%. Right, so the number of successes we can have is, we can have 0 successes, or 1 or 2 or 3, all the way to 10 if we have 10 attempts. Not very likely to have 10, nonetheless it is possible. So now we compute the binomial distribution by typing binomial dist, and then it's asking for the number of successes first, not the number of trials. The number of successes is the quantity here in the column to the left. The number of trials is 10 every time, so I make reference to that cell, and since that cell is always going to be the same cell as we copy the formula down, we have to use absolute reference. And then we have the probability. So in a similar fashion, we select that cell and do the absolute number. And finally, it's asking, do you want the cumulative or you would just want the probability mass function? The difference between the two is that the probability mass function is just the probability of having exactly 4 or exactly 7. The cumulative distribution would be the probability of having 0 or 1 or 2 all the way to say for instance 5, so it adds the probability of having 0, 1 or 2 or 3 or 5, etc. The summation of all these probabilities from 0 to 10 should add up to 1. So let's just use false for this first attempt, and then we can copy them because we use the absolute reference. If we add this column, it should add up to 100%. There you go. We can also use this formula to compute the cumulative distribution. So again, we have the number of successes, we have the number of trials, and the probability. But in order to consider the cumulative, we said true now. True being a binary function. And for all practical purposes, the last few numbers are so small that it's reporting the 1, but it's just because it's a rounding process. I'm going to stop the video here, and I will do another video to compare the hypergeometric with the Poisson distribution, with the binomial distribution, I'm sorry.